Hello dear friends, welcome back to Math with Amala. Let's start the part 4 of grade 10 chapter 1 real numbers. Here we are dealing with the Euclid's division algorithm which contains some exercise problems. Question number 1 is use Euclid's division algorithm to find the HCF of 135 and 225. Okay, so we have the Euclid's division algorithm like A is equal to BQ plus R. Here A and B are the numbers that we are taking as the divisor and the dividend, and Q is the quotient, also R is the remainder. Let's take 10 equal to 7 into 1 plus 3. 10 divided by 7 is actually remainder is 3 and the quotient is 1. Here you can give the Euclid's division algorithm format 10 equal to 7 into 1 plus 3. Now we have to check whether among these two numbers which is bigger. We got that 225 is greater than 135. So you can write like B greater than A. Let's apply this into the Euclid's division algorithm. 225 is equal to 135 into 1 plus 90. Here you have to note one thing. 225 is to be expressed in terms of 135. 135 into 1 plus 90. Here 90 is not equal to 0, which is the remainder. Again, you have to use the division algorithm for 90. If you apply division algorithm for 90, you have to write that in the form of 135 is equal to 90 into something plus remainder. So 135 is in terms of 90 means 90 into 1 plus the remainder is 45. Again, this remainder is not equal to 0. You have to apply the division lemma once again for 90. You will get 90 is equal to 45 into 2 plus 0. So you have got the remainder as 0. Now you can stop there. Now we can calculate the HCF from this division algorithm method. Let's write HCF of 135 and 225 is equal to HCF of 135 comma 90, which is equal to HCF of 90 comma 45. So we have got that the HCF of 90 and 45 is 45 because in the next step we got the remainder 0. So the highest common factor of 90 and 45 is 45. So we can write which is same for 225 and 135. Hence the HCF of 225 and 135 is 45. The second question, 196 and 38,220. Here it is clearly visible that 38,220 is greater than 196. So you have to find the HCF through the Euclid's division lemma. Let's apply it here. Euclid's division algorithm for 38,220. And you have to note that this number is to be expressed in terms of 196. So here simply you can say 196 into 195 is equal to 38,220, which means the remainder is 0. You have got that these two numbers are having the direct HCF. You can write in this first step itself. Just by applying a division algorithm for the first step, you got that the remainder is 0. This is the common number which is occurring as the factor, and also the highest one is 196. Let's take the third one. It's 867 and 255. Here 867 is greater than 255. Let's apply Euclid's division lemma for 867, which is equal to 255 into some number plus a remainder. So into 3 plus 102. Here you can find this number 3 in this way. Let's take 255 because you have to express 865 in terms of 255. So let's take 255 for 2 times. So the answer is 510. Okay, but this is not enough for 867. We have to move more. Means let's add one more 255. You will get 765. Again 255 is needed. Let's take 1020. But it have exceeded 867. That means we can stop by 3 255s. So that's enough. 255 into 3 will be a number which is less than 867, and the difference between these two numbers 867 and the 3 255s is 102, that is the remainder. That is the difference between these two numbers. Okay, now again we have to express this 255 in terms of 102 into something. Let's take 102 into 2 plus 1. You can give the same method in order to find how many 102s are completely there in 255. Then you will get the remainder 51. Again, this is not equal to 0. The remainder is not equal to 0. Let's take 102 in terms of 51. 102 is equal to 51 into some number. What will be the number? 51 into 2 plus 0. Hence, we got the remainder as 0. 102 is 51 into 2. Let's take the HCF from this last step. So, HCF of 867, 255 is equal to HCF of 255, 102, which is equal to HCF of 102, 51. We are going from the last step towards the first step. So, this is how you find the HCF. Thanks for watching the video. Please stay tuned for the part 5.